Let's understand constant time. It means no matter how big your data is, the time it takes stays the same. That's constant time. Imagine a shelf with 100 books. And you want the one at position 5. Even though there are so many, the boy walks straight to it and grabs it. Done. However, he didn't have to search at all, no matter if there are 10 books or 10,000. This means even if the data is large, the time taken will remain the same. Best example is accessing a number in an array. Let's say we have an array with 5 elements. If we want to access the value at index 2, the third item, we get it directly. The time it takes stays the same, even if the element is at the beginning or the end. There's no need to go through every element, even if the array has more elements. There is no looping or searching. In case of linear time, time grows directly with the size of data. Imagine a teacher is applying sanitizer to 6 students one by one. As the number of students increases, the time taken also increases linearly. If there are more students, it takes more time. This is called linear time, because the time increases step by step with the number of students. That's linear time. The more data, the more time it takes, step by step. Let's say we have a list with 4 elements and we want to print all of them. We use a loop to go through each item, which means we perform 4 operations. As the number of elements increases, the number of operations also increases. So, the time taken grows linearly with the input. This is called linear time. Quadratic time means the number of operations grows with the square of the input size. If the input becomes 2 times bigger, the operations become 4 times more. Imagine you have 2 shirts, 2 pants. If you want to match, you have to try different combination. Here's what happens. For each shirt, you try it with every pant. Shirt 1, pant 1, pant 2, same with shirt 2. You're doing n square times, which is 2 square, that equals to 4 tries. Let's go to logarithmic time. It simply means runtime grows logarithmically with input size n. Okay, imagine you're trying to find the word tiger in a big fat dictionary. Now, do you seriously start flipping from page 1 and check every word until you find it? Of course not. That would take forever. Instead, here's what you probably do. You flip the dictionary open somewhere in the middle. Let's say you land in the M section. Tiger comes after M, right? So now, you ignore the first half and flip somewhere in the second half. That's how you find the word tiger. You weren't checking every page, you were cutting the search space in half with every flip. That's exactly what logarithmic time, log n, means. Let's assume you want to search 40 in the list. We start with 2 points, one at the beginning, called low, and one at the end, called high. Now we keep checking the middle number of the list. If the middle number is the one we're looking for, great. We return the position. If the middle number is too small, we ignore the left part and move to the right. If the middle number is too big, we ignore the right part and move to the left. We keep doing this, cutting the list in half, until we find the number. That's binary search. It's fast because we don't check every number. Exponential time means the number of operations doubles with each increase in input size. If input size is n, then the algorithm may take around 2 steps. Imagine you're trying to guess a password, and the password is made up of only ones and zeros, like binary. Let's say it's a 2-digit PIN. Then you try 000110114 combinations. Now for 3 digits. You get 8 combinations. See the pattern? Each time you add one more digit, the number of combinations doubles. 1 digit, 2 digits, 4 3 digits, 8 4 digits, 16. And so on. That's exponential time, because for every extra step, the work doubles. Best example is Fibonacci series. Let's understand linear arithmetic time. It means an algorithm's running time grows proportionally with the input size multiplied by its logarithm. Example, imagine a singing tournament with 16 cool contestants. Round 1 has 8 pairs with all 16 singers. Round 2 brings 4 pairs with 8 singers left. Round 3 has 2 pairs with 4 singers. The final round picks 2 singers as one pair for the win. Here, n is 16, the total singers. Log n is the rounds where log base 2 of 16 is 4, taking us to the champion in 4 rounds. Best examples are merge sort and quick sort. We will learn these in our upcoming videos.